Hi guys, today we are going to learn about absolute value transformations. Now we've done transformations before, we did parabolas before, so if you recall, when you add a number at the end, it moves it up and down. When you add or subtract a number inside the parentheses, it moves it left and right. When you multiply by a number out front, it's a vertical stretch, vertical shrink. If it's negative, it's a reflection. If you recall all of those things, the same rules are going to apply here. Except now we're going to have a new function, the absolute value function. Now, we've done parent functions before. You did them in Algebra 1A. So this particular parent function is the absolute value of x. And so this is what the graph looks like. And remember, absolute value is always positive. So no matter what I put in for x, the y value is always going to be positive for the absolute value. And if you don't believe me, here's my Desmos calculator that shows... Yeah, I forgot to turn my ringer off on my phone, so that's okay. So my Desmos shows the graph here with the big giant V shape, and notice it's like a 45-degree angle, and that's perfect. So now to do the transformations, the rules will be the same as they were for quadratics and exponentials. So I wrote that right here. We will use our rules of transformations just as we did for quadratics and exponentials. So the transformed equation of a absolute value function is A times the absolute value of x minus h, where minus h is inside the brackets. That's your left, right, and then plus k is your up, down. So the rules still apply. If it's inside the brackets, it's a left and right. If it's outside the brackets, it's an up and down. If the number in the front is negative, meaning in front of it is a negative, then it's a reflection. Remember, that is separate from the number a. So whatever a is separate from that negative. So if a is bigger than 1, it's a vertical stretch. If a is between 0 and 1, it's a vertical compression. So those are your fractions. So I did several examples here for you, and you're going to see these when you get to, you can actually download these notes and print them or copy them, whichever works for you. So we did the absolute value of x minus 3. So I typed that in here, the absolute value of x minus 3, and here's my graph. So see what it did there? It moved so here's my parent function. Notice it's at 0, 0. This is always the point you're going to move. Just like before in the parabola, it was always 0, 0. It happens to be 0, 0 here too. You're going to deal with the vertex. That's the one you're going to look at. The overall shape is going to be a V shape. So for this one, the only thing I did was I moved it down 3. So if I zoom in, you can kind of see that that's a 3 right there, and see it's 0, negative 3. So all it did was move it down 3. So you would say that it is a vertical shift down 3. Okay, down here for 1/2, you will have the 1/2 out front and then the plus 4 inside the bracket. So if you look over here where I typed it in, the 1/2 out front and the plus 4 inside the bracket. Remember, f of x is the same as y equals. So the plus 4 moves it left 4. So it puts my vertex right there, just left 4. There's no up or down here. And notice what it did to the shape of it. So here's my parent function. Here's my new function. It made it way wider. And remember, wider is a vertical compression or vertical shrink. You can use either word here by a factor of 1/2. For number 3, the very last example, I kind of combined a couple of things here. I have that one in here too. That would be negative 3 on the outside. Notice what the negative did to it. So here's my function now. The negative made it flip upside down. It's a reflection. The 3, if you notice, look how much skinnier it is than that one. So the 3 gave it a vertical stretch, and then the minus 5 moved it right 5. So the negative in the front means a reflection across I actually give reasons here. On the classwork, you're not expected to give the reason. I only gave it here for the purpose of the notes. So a negative in the front means there's a reflection across the x-axis. The 3 in the front is separate from the negative. Don't look at it as negative 3. Look at it as negative and then a 3. The negative out front is a vertical stretch by a factor of 3. And the minus 5 on the inside of the bracket means a horizontal shift to the right 5. And once again, if you forget those, guys, I gave you the rules. I gave them to you several months ago if you still have the stuff from when we were in school. We had a nice paper that had quadratics on it that was very similar to this right here. So I've given you this document before. You just have to look for it. And if you don't have it, I redid it right here. It's very similar to this one. It doesn't look exactly like this one, but it's close. So just to recap, inside the grouping symbol, in this case, it's going to be those upright absolute value signs. Inside is your left and right. Added at the end is your up and down. Negative in the very front is a reflection. And the number in the front, whether it's bigger than 1 or less than 1, is a stretch or compression, depending on whether it's a fraction or a whole number. Please also keep in mind that A and K are different and do different things to the graph, so just pay attention to that. Several of you, when we did this before, mixed up the A and the K just because they're both outside. Is it plus or minus the number, or is it times the A, meaning it's crunched right up against that bracket? So please let me know if you have questions on this. I will walk you through any problems I need to. Thanks.